Hello and welcome to Digital Medboard. Here we go. Now we are going to discuss about the normal values and basic analysis of ABG. The normal pH is 7.36 to 7.44. A helpful trick to remember the normal PCO₂ range is to remove the 7 from the pH value. So the PCO₂ range is 36 to 44 mmHg. The normal bicarbonate level is 21 to 27 milliequivalent per liter. Step 1. Check the pH. If the pH is less than 7.36, it indicates acidosis. If the pH is more than 7.44, it indicates alkalosis. Even a normal pH 7.36 to 7.44 does not exclude the possibility of an acid-base disorder. In mixed acid-base disorders, the pH can still appear normal due to compensatory mechanism. For example, in a patient with both metabolic acidosis and metabolic alkalosis, one disorder can cancel out the other, resulting in a normal pH. However, this does not mean the acid-base balance is truly normal. To confirm normal acid-base status, all three values pH, bicarbonate, and PCO₂ must be within normal limits. If only the pH is normal, further analysis is still required. Step 2. Determine whether the disorder is metabolic or respiratory. To identify the primary disorder, examine bicarbonate and PCO₂. Bicarbonate is a major plasma buffer. In case of acidosis, a decrease in bicarbonate allows metabolic acids to accumulate. So, low bicarbonate equal to metabolic acidosis. Carbon dioxide acts as an acid, so its accumulation increases acidity. Therefore, high PCO₂ equal to respiratory acidosis. In case of alkalosis, excess bicarbonate neutralizes acids, leading to alkalosis. So, high bicarbonate equal to metabolic alkalosis. When carbon dioxide is washed out, example hyperventilation, the loss of this acid leads to alkalosis. So, low PCO₂ is equal to respiratory alkalosis. We got a question. Identify the acid-base disorder in a patient with the following values. pH 7.2, PO2 90 mm mercury, PCO2 80 mm mercury, and bicarbonate 35 milliequivalent per liter. The pH is low, indicating acidosis. Bicarbonate is high. This does not explain the acidosis, so it's likely a compensatory response. PCO₂ is very high, which does explain the acidosis, indicating a primary respiratory acidosis. The increased bicarbonate reflects renal compensation for the respiratory problem. Therefore, the correct answer is option D, respiratory acidosis. If you found this video helpful, don't forget to like, share, and subscribe to Digital Medboard. Got questions? Drop them in the comments below. See you in the next video. Until then, stay tuned. Choose.